Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM Arts students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.
Hi everyone, welcome back to another episode of Space on Earth. I'm Taylor.
I'm Tulsi.
And today we're going to talk to you guys about comets. Comets are a really cool phenomenon in our universe, and I was lucky enough to actually get to see a really incredible comet around this time last year. And I was driving with my family. I really wanted to see it, and we planned out the right time and view and stuff. And we're all kind of expecting a small light in the sky, like maybe a bit of a streak behind it. And we drive into town a little bit, pull over, and the view that I saw was just so incredible and so jaw-dropping. This incredible bright light in the sky with a long tail behind it. And I just felt so amazed. And I just thought it was really incredible.
Wow, that's a really pretty story. But what is a comet exactly?
I'm glad you asked. So comets are pretty cool, and the definition of a comet is it's a small solar system body made mostly out of ice. And, that's more than just water ice. So you're getting even more different materials in there. So it'll be frozen gases, mostly water, carbon dioxide, ammonium, and it's also made of dust. And these are formed in the outside solar system. Think of comets as the leftover scraps from when a solar system's being built. Most of that matter that is going around the sun and in the space clumps up into planets and stuff, but a lot of it ends up being little comets. And those that are really far out from the sun, like I said, are going to be made of materials like ice and frozen gas. And as those get closer to the sun, what happens is the frozen gas, it sublimates, which means that it goes directly from a solid to a gas. And that creates this really beautiful glowing tail behind it. And the structure of a comet is, you think of it as a nucleus with a really solid core. And there's a coma around that, which is a fuzzy envelope when it's active. Basically just a lot of that same material, but just a little more gassy and spread out. And then behind that is the tail. Tulsi, do you want to talk any about the origins of comets?
Yeah, so many of them actually come from the farther reaches of our solar system, so around the Kepler belt, or are just scattered around. And that's because they're actually made of the matter that created our solar system. So they're kind of like relics of the matter that created our planets and solar system. So they're like time capsules.
So Tulsi, when you see a huge comet with a really amazing tail, which is kind of the iconic image of a comet, where does that tail come from? What is that exactly?
So the tail basically comes from when solar wind and radiation push the gas away from the sun. And so the tail will always point away from the sun. And as that radiation and heat hits it, it'll kind of start to melt. But since there's not enough pressure in space for it to become a liquid, it just goes straight to gas. And so it turns into a tail, which is what we see. Also when it burns up in our atmosphere. But there is a difference between a comet and an asteroid. So do you want to talk about that?
Yeah, sure. So people often get comets and asteroids mixed up, which makes sense. At like a pretty base level, they're pretty similar, small like bits of mass and different materials in space. But the main difference is that asteroids are mostly rocky and metal materials. So that's a lot of stuff that's being formed closer towards the sun. So think about like asteroid belts that are closer to the inner solar system, and also think about the planets that are in the inner solar system. Most of that composition is rocks and metals. And so asteroids are going to be pretty similar, just like how comets, being from the outer solar system, being around planets like Neptune and Uranus with really icy makeups and materials, that the comets are going to be built the same thing. Also, comets show activity when heated, asteroids don't really change. So that's the main difference. And kind of like I was talking about the different materials, there's some link to like different biology and ecology with the materials in comets. So there's information that shows that comets may include organic molecules and maybe even delivered some water organics to early Earth. So that really brings in a cool like image of early biology and geology here on Earth and how our planet interacts with other stuff in space. So that I just think that that's a really cool fact. Tulsi, do you have any good like visual descriptions or just like metaphors for what a comet looks like for any of our viewers who haven't seen one?
Sorry. Yeah. Yeah. So when I imagine a comet, I kind of think of like a really dirty snowball that's just kind of floating in our solar system on like the outer reaches. And it wants to visit the sun, or it's kind of floating towards the sun. But as it does that, the sun is obviously melting the snow. And so it lets off a tail of gas and dust that glows, if that makes sense.
Yeah, and a really cool thing to know about comets is, like we said, all of that matter and debris gets taken off of the comet, but it doesn't really go anywhere. You know, matter can't be destroyed or created, and so everything ends up somewhere else at some point. And a lot of times what happens with comet debris is it gets left kind of in our solar system in the area, and that's what creates meteor showers. So, fun example, the Orionids meteor shower that's going on right now is the current one. A lot of that is leftover debris from Halley's Comet. So that's a really interesting thing to keep in mind is how much cause and effect is in the world around us. And Tulsi, I brought up how, you know, some of our viewers probably haven't seen a comet. You know, you haven't seen comets before. But
No.
for those of you guys listening, you're in luck. There are two really amazing comets that are visible right now. Tulsi, can you tell us a bit about them?
Like Taylor said, you guys are really lucky because there's two notable ones that you can see in October of 2025. One of them is Comet Lemmon, which was discovered all the way back in January and is visible to the naked eye. So there's a good chance you can see it after dark, or at least after sunset. If you look toward the northwest or around the Big Dipper region, and the two stars that are the handle of the Dipper will actually point you directly toward the comet if you need more help. It's going to look kind of like a lime green or glow in the dark paint kind of glow, which is due to carbon molecules, and they emit that kind of green glow in the dark look. The second comet is the comet SWAN, which was discovered pretty recently, only in September, and by the SWAN instrument on the SOHO spacecraft. Its closest approach to Earth is around 24 million miles, which will be on October 19th. So it's slightly closer than Lemmon. But even though it's closer, it'll probably require binoculars and not as much naked eye. You can't really see it as much just using your eyes because of the brightness and distance. But if it's dark enough, you could still see it with the naked eye. If you want to find it, I would look after sunset around southwest, like maybe the Summer Triangle region, which is where the stars Vega, Deneb, and Altair, I would use a pair of binoculars or a small telescope just because it really is kind of harder to see with the naked eye. I would find a dark sky location if you want to go maybe hiking or out into just maybe a less crowded area that might not have as much light pollution. That might help. And I would look shortly after sunset or just before dawn when the sky is darker, but it's still above the horizon. And for Lemmon, I would look around sunset to the northwest, but for Swan, I would look after sunset to the southwest.
Also, if you're ever finding a hard, like if you're ever having a hard time looking in the sky and trying to like find different things, there's a ton of different mobile apps that you can get that use tracking and augmented reality to help kind of map out the stars in front of you. I really like using those. If you just search like stargazing apps on your phone, I love those because I can like easily find stuff. And so it's definitely, it helps to kind of like get that experience. But, finding a comet, it might sound kind of complicated to see, but it's a pretty easy thing that anybody could do. And that's such an amazing part about outer space is that anybody can just go look at it and it's something that we can experience. So that's some good information to know about how to find comets, you know? Tulsi, do you have anything else to add about how to find them?
I mean, definitely find a darker sky, look after sunset for sure. The weather does matter. I mean, at the moment, it's pretty cloudy and you're not going to see much of anything in the night sky. I would wait for a clear night, obviously. And moonlight also matters because the brighter the moon, it might reduce visibility. Anything else to add? I think that's
I have some like quick extra facts to add on at the end. So, kind of like I said about how they may have delivered water and organic molecules to early Earth, comets are really, really old. And a lot of these leftovers from the solar system's formation can be about like 4.5 billion years ago. So, as they're bringing in a lot of information to like early Earth geology and biology, they're also giving us a lot of information about the chemical and material makeup of what the solar system was like at that time, which is really just helpful information to have. And a few other things is there's two different types of tails when you're looking at comets. So one of them is a dust tail, and you can tell a dust tail by if it curves or not. And the other type is an ion tail. So this is what I saw on the comet that I saw, where it's straight and this like blue line, which is really incredible to see. And to kind of put into context how incredible it is that we can see comets and how like large scale they are through time. The ones that we're seeing right now, so Comet Lemmon, for example, this is probably its first time in our inner solar system in about like probably like 1,350 years. So this is a pretty once in a lifetime event. And that's just like a really cool way to think about it. So, yeah, basically, that's what comets are. Some comets that are visible now and how to see them. So, our hope for you guys is that you walk away knowing a bit more about comets, that hopefully you get to see either the Lemon or Swan comet, and we'll go find those two. And thank you, as always, so much for listening and supporting us through this podcast. We are so grateful. And if you guys have any ideas, any questions, feel free to reach out to us. We would love the feedback and would be super happy to do an episode about your suggestions. So, if you're curious about anything, that's why we're here to learn a bit more about space. I'm Taylor,
I'm Tulsi.
and we'll see you next time.